Okay, this is the final part of the training video. This is the inference part. And it looks like there's probably going to be 3 additional videos. This video is just going to be kind of an introduction to inference, give you some ways, some ideas of motivating the concept. There's going to be an additional video on confidence intervals. I'll go into, well, I haven't made it yet, but I know what I'm going to do. I'll go into examples, motivations, and things to try to get your students to be thinking about. And I'll also give you some things, some information behind the scenes that you probably wouldn't want to share with your students, but you may. I don't know. It just depends on how bright the kids are that you're teaching. Guys, inference, I think, is a great place to step back and reflect and think about what you've accomplished. And you're here because hopefully you've learned something about descriptive statistics, normal distributions, and sampling distributions. And it all kind of comes together to create the framework for inference. Guys, it's important, again, to step back and think about what's known and unknown. In sampling distributions, where we determine probabilities of getting particular random events, the population values were known. What we got from our sample was unknown. That reverses an inference. What's known? We've got a sample. We've collected the measurements. We know the mean. We know the standard deviation. We know the sample size. But what's unknown is the value from the population that we're either trying to estimate or come up with a test about a particular claim of a value from a population. So start smart. What I mean by this is start with questions. Something I use, and actually have carried this out. How long on average do drive-thru customers at Tim Hortons wait until they receive their order? That's something kind of cool. Number 2, what percentage of students at Shawnee State or your local high school has a Twitter account? The way these social networking sites are popping up seem like almost monthly. There's probably something out there cooler than Twitter, but it's just not cool enough to know about it. Number 3, what's the average IQ for all nurses? And finally, have your students come up with some questions that they think is possibly interesting to study. You'll be shocked at some of the things you'll hear. At least I'm shocked at some of the things I hear from college students. Some of them actually make you blush a little bit. All right, guys, pose questions. Let's assume we really care about the average wait time for customers at Tim Hortons. Probably not. It's an academic exercise, but nevertheless, let's assume we care. Where would we start? Well, first thing we'd have to do is we'd have to decide how we're going to take our sample. And there would be ways that we could come up with convenience samples. We could just go hang out one morning and watch 15 cars and take some measurements and start constructing some techniques in inferential statistics. But we probably wouldn't be able to generalize much more than just the average wait time at that particular time in the morning. But so what we'd probably want to do is you'd want to get your students to think about how would we collect the data. Well, chances are you'd want to go on different days of the week. You'd want to go at different times of the day. And you'd want to try to create, again, something that was representative of a random sample. Something else you need to motivate is this thing called sampling variation. I know a lot of really smart people who screw this up regularly. First of all, sampling variation, it's to be expected. It's going to happen. How we explain it is very important in the techniques of inference. For example, let me tell you what happens here. Someone claims that the average ACT at Shawnee State University is 21, and they don't even claim it. We have on record 21. So someone decides that they're going to come up with a method by which they can improve ACT scores. So they choose 30 people, they go out, go through this program, they take the ACT again, and their average is 21.4. Well, everyone knows that 21.4 is bigger than 21. But guys, those are comparing apples and oranges, because the 21.4 is from a sample, the 21 is from the entire population. But a lot of people will want to treat that 21.4 from our sample as if it's gospel, holy, and perfectly representative of the population. It is not. It is one sample out of infinitely many. That sample would vary if we took another sample 2 seconds later, a week later, a month later. So we expect sampling variation. So in the end, we have to treat our sample value very carefully, with kid gloves, if you will. Realize when we collect sample, we take our measurements. There's nothing holy, there's nothing grand about our sample, but it's the only one we've got, and it's the one we use to make important decisions. Z-test. Guys, used to be Z-test and Z-intervals were covered in almost every statistics textbook. Now, the fact is, most of your more, or at least many of the popular textbooks written today no longer cover them. So what I'll focus on are t-test and t-intervals. That pertains to quantitative data, and something called one proportion z-test and one proportion z-intervals for categorical data. If we can get our students to understand these four concepts, the two branches of test and confidence intervals, and the two branches of hypothesis testing, we'll be some very, very, very happy campers. Motivating problem number 1. This will be the motivation for the t-interval and the t-test. So the mean emission level for a new design of engine is unknown. Random sample of 10 engines is produced, so the emission level can be examined. You got the results. Estimate with 95% confidence the mean emission level for all engines with the new design. That's the t-interval part. The second bullet, use the random excuse me, use the random sample to test the claim that the mean emission level for all new designed engines is 20.0. Guys, we're going to work both of those problems in the next two videos. Motivating problem number 2. What percentage of households has high-speed internet service? Unknown to me. I don't know about you. A random sample of 150 households is examined. It's found that 58 have high-speed internet service. Estimate with 90% confidence the percentage of all households that have high-speed internet service. That is the one proportion z-interval part. The second bullet, use the random sample to test the claim that the percentage of all households with high-speed internet service is 30%. So guys, when we get into hypothesis testing, I feel that your students should understand 3 methods for carrying out a test of hypothesis: the p-value approach, the critical value approach, and the confidence interval approach. And be advised that the confidence interval approach only works when conducting a two-tailed test. So guys, that's the end of this video. Again, the next two videos, the next video will be on confidence intervals, and the final video, well, not the final video, but the second video after this will be on hypothesis testing, and the final video will be just more of a comprehensive question illustration using R to carry out some some confidence intervals and test of hypothesis.